let's solve this trig equation. So at GCSE we would have just done sine inverse of 0.7 and that we would put in the calculator to give us 44.4. We'll work to one decimal place. And that would probably have done you. However, now that we know that sine can be defined not in terms of a triangle, but in terms of a circle, we know that our graph can just continue oscillating forever. In this case, we've been told that we should limit x between 0 and 720. So that's what I've done here, 2 complete oscillations. And I know that I need to try and find where is x equal to 0.7. So remember that we have a maximum value of 1, a minimum value of -1. I would expect 1, 2, 3, 4 solutions to this. So I should find those 4 solutions. Using my graph to help me, I know that from where I'm at 0, I have to move across 44.4 degrees. So here, from where I'm at 0, I know there'll be another solution if I move back 44.4 degrees. Remember, this graph is symmetrical about that point. So if I do 180 minus my answer, I'll get my second solution. Now how do I find these extra solutions? I know that my graph repeats every 360 degrees, so if I just add 360 degrees, I can get the next solution. And a similar argument applies to this solution. It repeats every 360 degrees, so if I add 360 to this, I will get that solution there. We're expecting no more solutions. If you want to, you can add 360 to this again, and you'll see it falls outside of our set of x values. If we wanted to find values lower down, let's for the sake of argument say this actually extended to negative 360, we would just apply the same kind of logic. The graph repeats every 360 degrees, so if we just subtract 360 from each of these, and that one as well, we would get additional solutions down here. Okay, so once you've got your primary solution or your principal solution, then we use our graph to find the second solution. We would do the same for cos, and then we just add or subtract 360 from our 2 primary solutions. Okay, let's just do a similar one for cos and tan, and we'll just check how they work. So if we've got cos now, let's have a negative one. Start the same, just like at GCSE, inverse cos of minus 0.3 gives us x is 107.5. Quick sketch of the graph. I'm expecting 1, 2, 3, 4 solutions again. As a general rule, every 360 degrees gives you 2 additional solutions. So here we've got 2 lots of 360 degrees, 4 solutions. The only exception to that is if you're at these maximum points of 1 or minimum points of -1, as there you get a single solution. Okay, so let's have a look at that. 107, how do I get this second solution? I know I started at 1 and travelled 107 degrees forwards. So to get this second solution, I go from where I start effectively, but now I travel backwards. So 360 minus my answer gives me 252.5 degrees for both. I can now just add 360 to both of those. I've got my full set of 4 solutions. And again, I wouldn't expect any others. Finally, we'll look at tan graph and how we can get multiple solutions from that as well. So remember, tan can be greater than 1, sine and cos cannot be, so we will get solutions to this. Inverse tan of 5, 78.7. Again, just remind yourself of the first ones that you do. Quick sketch of the graph. Doesn't need to be deadly accurate. And as you start to do more of these, you'll learn some shortcuts. 78.7, it repeats every 180 degrees. So now I'm just going to have to add 180 to get my following solutions. No need to type it in again every time, just press equals. Keep going because we're not up to 720 yet. One more would take me too high. Again, we got the 4 solutions as we expected for 2 complete oscillations between 0 and 360. Okay, that's how we're going to solve and find all of our solutions at A level.